Last part on recognizing and notating functions. So here is just looking at identifying and understanding the what's called a restriction of a function and being able to state the implied domain. So if we look at these three functions here, okay, f of x equals x squared, g of x also equals x squared, and h of x equals x squared. The only difference with these three is that they all have different domains. So even though they're all defined by the same function, we use different letters to denote what they are because they have a different domain. So it means they are a separate situation. So we refer to these as restrictions of the original function f because their domains are subsets of the domain of f. So f of x wholly contains g of x and h of x in this case, but those are subsets, so we refer to them with a different letter. For part A here, we want to, for both of these, we want to sketch the graph of these functions and state their range, and we've been given a domain here. So for f of x equals x, all that's going to look like is that. Okay, it's y equals x. We're just using different notation. But we want to make sure that we are bounded by this domain. So x is going to go no further than -1, which would be there. And we're using a solid dot there because it can be less than or equal to. And it can't go any further than, let's put 2 here. Okay, so that would be our line. Okay, that is the restriction of f of x equals x given that domain. For our second example here, x squared plus x is just our basic parabola moved over and down a little bit. It's going to have an y-intercept at 0, 0 there, and a turning point of 0.5, negative 0.5, negative 0.25, so 1/2 1/4. Our domain here is between, when x is between -1 and 1. Easiest way to sketch something like this, given our domain, is just to work out what those endpoints actually equal. So what is f of -1? Right, so that's going to be -1 squared minus 1, so 0. So when x is -1, y is going to be 0, which means that point there is going to be the start of our function, our restricted function, and then f of 1 is going to be 1 squared plus 1, which is 2. So if we go sort of 1, 2, it's going to be about there. So if we were to redraw our parabola, we know it's going through 0, 0, so it's going to look something like that. Remember, we're just sketching, so it doesn't have to be perfect. We really just want to be representing sort of where these points are. So we would label that this is -1, 0, that there is 0, 0, and this is going to be 1, 2. Now for some of these functions, they're going to be types of graph you haven't seen before, and that's okay. As I said, just go over to Desmos, graph it, have a look at what it is for when it's asking you to sketch them. But you should still be able to state the implied domain of quite a lot of these just by sort of using your common sense. So for example, part A, this is a kind of graph you haven't really seen up till now, but we know that the rules of maths, for it to be a real number, you can't take the square root of a negative number, right? So this is only going to be a defined function when 2x minus 5 is a positive number. So 2x minus 5 needs to be bigger than 0. Okay, so if we work out what value of x that's actually going to give us, we get 2x is bigger than 5, and x is just it has to be bigger than 5 on 2. Now, the type of graph this actually looks something like that. It's sort of a sideways parabola, if you like. So we know that x has to be bigger than 5 on 2, so it's going to start about there. And if we think about the values of the range, so the values of y, when x is bigger than 5 on 2, so we know we would write our domain as being 5 on 2 up to infinity, because it can be any positive number there. That's going to look like that. Our values of y, therefore, so our range, are basically going to go from when x is 5 on 2, so I guess it can be equal to and all of those. So when x is 5 on 2, your range is going to be 0, and that range is also going to go up to infinity in this case. Oops, sorry, that should be a curvy bracket up here as well. For example B, again, not a type of equation that you're necessarily familiar with, but maths rules dictate we can't divide by 0. So we know in this case that 2x minus 5 cannot be equal to 0. Okay, so we can solve that in the same way we did before, saying 2x basically can't be equal to 5, x cannot be equal to 5 on 2. I'll show you what this kind of graph looks like, just so you can get kind of an idea, but what this effectively means is that because x can take on any value other than 5 on 2, we would write our domain as being real numbers excluding 5 over 2. So the graph would look effectively like that. Our range in this case is actually going to be r excluding 0, because there is no way to get a value of 0 here, because we're always 1 divided by something. You can't get a value of 0 that way. So that gives us our range. That last example, part C, our equation is, it's just a translated parabola, so it's going to look like that, which means our domain, our implied domain, is just going to be all of the real numbers, and our range here, we've got a maximum of 4, minimum of negative infinity. So that would be our range there.